Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great webinar, as always, on tap. But before we get started, we have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to the webinar on demand. We'll be sending out an email after today's event that will contain a link for you to access the webinar. And we are taking questions from the audience. So if at any time during today's webinar you have a question for our panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take a few minutes near the end of today's presentation and go through as many audience questions as we can. And finally, also at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So stick around. Hopefully you'll be one of our 3 lucky winners today. Okay, with that, we'll go ahead and kick off today's DevOps.com webinar, which is Mainframe DevOps using Zowe open source. Our speakers today are Michael Bauer from Broadcom and Joe Winchester from IBM. Welcome, gentlemen. Thank you so much for joining me today.
Thanks, Charlene. And hello, everyone, and thank you for joining today's webinar where, as Charlene mentioned, we'll be discussing Mainframe DevOps using Zowe open source. So just a little bit about myself. I'm a product owner here at Broadcom, working out of the Pittsburgh office. Stanley Cup playoffs just kicked off, so go Pens. I'm responsible for the CA Brightside command line interface, and I'm also the squad lead for the Zowe CLI component of Zowe, which is the first open source project based on ZOS. Joe, would you like to say a few words about yourself?
Sure, thanks, Mike. So my name is Joe Winchester. I am British, English. I work for IBM, and a little bit of background, I've worked on a couple of open source projects before. Most notably, I was a contributor to Java, and I was a team lead on Eclipse. And I'm very proud to be part of the Zowe initiative for the Open Mainframe project. I've been working on the mainframe for about 15 years, and I'm the lead of what's called the Zowe Extenders Squad, Zowe Onboarders Squad. So our mission really is to make Zowe successful for end users and also to try and get as much adoption by having the surface area of Zowe's reach in terms of products as wide as possible. Thanks, Mike.
All right, thank you, Joe. So transitioning to today's agenda, so I'll kick it off by providing a brief Zowe overview. If you're interested in a more detailed overview, you can view the introductory webinar, which is available on demand at devops.com. It was originally presented on March 28th. Then I'll turn it over to Joe, who will discuss the API Mediation Layer component of Zowe and provide a demonstration. And then I will provide a demonstration on the Zowe command line interface and discuss how it will enable you to integrate your mainframe applications into your enterprise DevOps pipelines. And we'll wrap up by taking some questions from all you folks on the line. So just at a little bit of an overview about Zowe. It's an open source mainframe interface for the next generation. So it bridges enterprise DevOps to the mainframe. It allows you to make use of modern industry standard open source tooling, and it shifts the mainframe balance of power from vendors and proprietary to the community. So if there's something you would like to see that would help you be more effective, feel free to contribute or even just suggest ideas, and the community can help drive those home for you as time goes on. Just providing a brief overview of the Zowe framework. So core Zowe consists of these main components: microservices, the API Mediation Layer, CLI, web desktop, as well as a VS Code extension. The idea is, as microservices become available on the mainframe and become numerous, there's many of them, you'll need a means of managing them effectively, which is where the API Mediation Layer comes into play. And then you will have clients who make use of this functionality, such as a command line interface, which is useful for scripting purposes, as well as a graphical user interface in the form of this web desktop. So you may have heard terms Zowe, and you may have heard the term bright side. I just want to clarify a little bit about this association. So the Zowe CLI, API Mediation Layer, as well as the VS Code extension were originally built as part of Brightside, which was an offering from Broadcom, but was later contributed to Zowe open source, and now Brightside is positioned as Broadcom's support offering for Zowe. So with that, I will go into more detail on both the API Mediation Layer and the CLI components, and I'll turn it over to Joe to start the piece on the API Mediation Layer. Joe?
Great, thanks, Mike. So the first thing I wanted to do before I dive into the API Mediation Layer and what it does is I'm just going to cover a little bit of background that hopefully is useful, which is why an API Mediation Layer is so important. So this is a typical sort of topology that I've drawn a picture of here, which is with any client-server application, the servers being at the bottom and the clients being at the top. What tends to occur is somebody builds a particular server with services it provides some end-user function, and then they deliver a client that is installed on a desktop, or it runs inside a web browser, or it may have a command line interface whose purpose is to make user-friendly in terms of presenting or visualizing, putting a human in front of operating the server's function at the back end. And with the mainframe, because the mainframe is actually coming up to its 55th birthday this year, what you find when you go and visit mainframe customers or when you look at a mainframe site is that they have many of these built over different time periods. So some are green screen, some might have clients written in Visual Basic or Java, Eclipse, rich desktop. Some might have more modern interfaces written in web browsers, but you have a very heterogeneous mix. And what you have is every customer's machine has multiple clients built using different user interface sort of paradigm technologies that have to have intimate knowledge of where the server's endpoints are located. And first of all, that increases your, if you can go back one more, Mike, thanks. It increases, well, it gives you lots of points. It gives you a client server configuration issue that needs to be tackled. The next slide that Mike's showing, credential challenges. Each client has to sort of independently authenticate to the backends what its user ID and password is. Mike, is it possible to go back one slide? Great, just hold it there if possible. So what I've done is I've just shown some boxes, and they're just sample boxes, and this is something that's very typical to anybody that's used, used the mainframe, or you might have to re-enter your user ID and password multiple times. And this decreases your usability, and it also means that you have to have a persistent password. And the problem with persistent passwords is that they're vulnerable to attack because they can be stolen from the weakest point that password is reused. It might actually be reused outside of the enterprise, and that can be a security risk. And the enterprises are moving towards single-use passwords and multi-factor authentication. So, and the third slide, if you can go forwards, Mike. Thanks very much. So when you have different clients talking to different servers, when you're dealing with TLS and you're dealing with certificates, so the servers have to present certificates, you end up with a certificate management problem, which is where you have to, the clients have to sort of independently trust and verify that that certificate is a trusted certificate. You end up with certificates that are self-signed rather than a trusted authority. You end up with cross-signed certificates where it's signed for one particular server and copied to another. And you basically end up with in a world of hurt. And there's one more animation, Mike, which is for anybody who's written a web client that tries to connect via SSL to multiple servers, there's a particular security risk that most browsers won't let you bypass, which is called CORS, cross-origin signing, which is where there's an attack vector, which is where the server on the right could be trying to steal information from the server on the left. So browsers really don't let you do this type of thing. Okay, so these are all the challenges. And the next slide, please, Mike. They're solved by an API gateway. So the API gateway gives you a single endpoint that you have to connect to. It gives you a single certificate it presents. It's what's called a facade pattern, in that it hides all of the complexity of the underlying services at the back end, about how they authenticate themselves, about their endpoints, through a secure gateway in front. That is the purpose of an API gateway in an enterprise software stack. It gives a much smoother user experience because transitioning between these, all of the problems that were presented in the previous 3 slides are removed. Okay, Mike, next slide, please. Okay, so that was really the background. I didn't want to jump straight into this slide without covering the background. So the Zowe API Mediation Layer. So it's a very core part of Zowe. It's based upon the Netflix Zowe framework. So if anybody just Googles for Netflix Zowe or familiar with Netflix Zowe, it's based upon that same technology. I was in a particular presentation once when I talked about it, and somebody in the audience sort of started clapping and thought that they could start watching videos on Zowe. You can't quite do that yet, but it's the same tech that Netflix uses for their video streaming service. It's an open source tech, so we basically used it within Zowe. So we haven't built this from scratch. The reason it's called the Zowe API Mediation Layer is it actually has 3 core components. So the first component, if you look in the middle, is called the API Gateway. And this is what really is a single endpoint for access to services. So all clients, which is above the line, which I've drawn a little graphic here, we can see some Zowe desktop. We have some user interfaces that are able to talk to the gateway. And the gateway is able to find, in the sort of 3rd row down, the services that are needed. And the 3rd row down, if you have a look, there's quite a myriad of ports. I think we've got about 8 or 9 ports in flight there. It's able to hide all of that complexity. And also, Mike's going to cover the command line interface on the right, and the CLI likewise is able to talk to its services through the gateway. Now, within the gateway, the gateway also has 2 other important components to it. So the mediation layer, one of which is the API catalog, which is, if you think about a gateway as providing all of these services, it's nice to be able to ask the gateway and say, well, what services do you have for me? And also, if the services themselves are REST APIs, REST API has a metadata format known as Swagger or Open API, and it's nice to be able to see those and start to test those out. And that's provided by the API catalog. Within this tech as well, because it's based upon Netflix Zowe, it provides API workload balancing. So if you have multiple services at the back end that are able to provide the same, so multiple server instances that can provide the same service, it's able to basically dispatch work to the most available one of those servers. So it gives you an element of scalability, sort of workload scalability, and also through the Sysplex distributor on ZOS, it provides workload balancing. And I've covered ZOSMF at the back there. Now, we do not ship ZOSMF. ZOSMF is a core component of the ZOS operating system. But ZOS, we connect to ZOSMF, and that's very much a core part of the function that Zowe can provide. And I've just written some examples. It gives you access to REST APIs for workflows. You can issue TSO commands, MVS commands, and you can also access the file system and JES. But we also provide support for other APIs on top of that. What I'd like to do now, Mike, is if I can take control, I'm just going to go to a quick demo. Awesome, thank you. So hopefully you guys can see my screen. Now on my screen, I'm going to show 2 demos here. I'm going to show one demo of the base API mediation layer that we ship with Zowe, and I'm just going to rattle through it quickly. And then I'm going to show a second demo of an API mediation layer that's been extended with more services. Just to reinforce the point that the base that we ship delivers a bunch of function, but it's not closed. One of the taglines we have with Zowe is, well, we want Zowe to extend to be an extensible framework. Open source doesn't just mean that you publish all of your source for people to read. It means that you provide us, we provide lots of extension points. We're a very extensible framework. And we want to invite other people to extend our framework in terms of adding new services below the API gateway, what's known as its southbound edge, because it's an edge server on the edge of your network, and also new function northbound in terms of the client's northbound. So you can extend the command line interface through plugins, and you can extend the user interfaces, web user interfaces as well. So these are the base services that we have available. And each of these, if you could visualize the chart that Mike was just showing, they respond to some of the boxes on that third row down. Let us get at Unix files, jobs. We've got 3 user interface servers here. So these are the instances that we have currently registered. Just going to rattle through in the space of time. This is the API catalog server that I talked about just now. One thing that I'd like you to keep an eye on is the 26502, just to make sure I did. So the 26502, so if I go and click here, COS files and datasets, we can see we have COS files and datasets. And here we have external documentation. And the external documentation link will take me here. So we have the Swagger. Ooh, I'm just going to collapse that, doing a little bit of testing. So for people who are familiar with Swagger, you'll see we have Unix files. And I'm just going to very quickly rattle through and do a demo. Winch J is me. I'm going to hit execute, and these are my data sets. I can get back up here. I can do one that's perhaps particularly more interesting one, sys1.p star or something. Whoops. P star. And execute that, and that should send me all data sets. And what's interesting about Swagger is that then I can pick up that URL if I wanted to, and I can just go over here. You can see I was preparing this demo beforehand, and I can just start typing in. So what's nice about REST APIs, for people who aren't familiar with REST APIs, is that they're very easy to sort of read and format. They're very human readable, but they're also very easy to write clients to talk to REST APIs. And the API gateway is also, if I come back to my Eureka client, we can see I have a client here called Explorer MVS. That's actually some user interface. It's not, the gateway isn't just for user interfaces, 26502 as well. It can actually be used not just for APIs, sorry, it can be used for user interfaces as well. So this is just a dataset explorer, and I'm just very quickly, just so I haven't got any secret sauce up my sleeve, switch to my network tab and clear it out for my browser, and I'm just going to go and twisty that bad boy right there to get a list of datasets. Just going to do it again, just assume it hasn't cached it, because I was testing earlier. Here we go. So if I go and look at my network tab, you'll see, okay, it went, that user interface on port 26502, which is my gateway port, fired off that URL right there. And you can sort of see what it's going to do. It's going to get the members of a data set, and again, I can crank that out right here, and I can get the same members of the data set. So that's a very whistle-stop tour of what an API gateway and an API catalog and an API discovery service let you do. So I'm just going to recap that very quickly. The API discovery lets you see all of your southbound services, which can be a mixture of user interfaces. It can be APIs as well. The API catalog will render the APIs for you, tell you who has declared they have an API. From there, you can basically look and see start exploring those APIs. And then for the ones that have Swagger, you can start testing them and using them. The next demo I'd like to do, I'm going to go to the left. I've got another server set up. It's actually a colleague of mine who works with me at IBM. It's a different port. It's a different catalog. And if we look, there's some more stuff available here. There's something called JSOS, which wasn't on the previous one. Let's see if I can actually line the two up side by side. Okay, so there's a few more things available. So JSOS isn't on the previous one, and CPU. So I do have a chart to show how this occurs, but very quickly, there's more southbound servers on this particular one. It's been extended, and it was extended through public APIs. So this is a richer catalog. I can see I've got some of these in the base. I think 1, 2, 3, these 4 in the base. These 2 are new. CPU usage snapshot is you. I'm just going to go and have a look at what that CPU usage is, and its overview of CPU usage. And I'm just rattling through these If I click that link, it would take me here. It's just that there's a new API that's available, and if I hit execute on this one, I get some CPU stats. If I hit execute again, perhaps this is a slightly nicer one to use. I'm going to try it out on this one and execute and execute. Did I get a failure error? Let me go back. It was working beautifully for me earlier, where I was showing the breakdown of my CPUs. Here we are. So we've got some CPU breakdowns. Okay, so that one didn't work, so apologies for that. But what that would have shown me is it would have shown me some breakdown of some CPUs. There's just a problem with that back-end server. Didn't work live for this demo. And this was actually used recently. Someone in the community called Alex Kim, he works for Vicom, and he did a really neat demo that was actually showcased on a webinar recently that the ONP hosted, was where he actually hooked up an Amazon, the Alexa voice-activated client, where he was asking it questions like, how's my CPU, what's my SLA, and he was basically calling these. So having APIs behind the gateway with the single port, Swagger defined, it opens up the sort of surface area of clients that you can get available. Now, if anybody's interested in how that got there, that's all covered. There is a sample for that, which is in GitHub, github.com/Zowe, CPU usage sample. It's all there. We're an open source project, so we try not to do things in secret. We try and work with source code in GitHub. We have very transparent conversations within Slack. We have calls that everybody's able to join. And also, if anybody wants to extend and find out more about the API mediation layer, if you go to zowe.org, and if you start reading our documentation, and follow the documentation and follow the extending tab, you will see there's a lot of really rich information about developing for the mediation layer. And it talks about the security and how to onboard with Spring Boot and how to onboard without Spring Boot. And Mike, if you could just take back control, I'll just cover a little bit about the difference between those two. Thanks, Mike. Okay, so this topology, actually, Mike, can you just go back one chart really quickly? I'll try and do it before and after. Thank you. Look, okay, so this is the base. This is the first API mediation layer topology that I showed you that had our base set of services, and I showed the MBS, REST APIs, and the MBS UI, which is one of the things up in the top left, and showed that they were all using the same one. If we just pop forward to the next slide, please, Mike. And this was the second API mediation layer that I showed you. So there were two new services added to the back end, one for getting at mainframe CPU, and another one which I didn't demo for the sake of time, but it basically got at some more function. Now, there's two ways that the API gateway can be extended. So if you look at down the bottom, adding new servers southbound is really the power of the gateway, is that there's lots of existing function on ZOS. There's actually lots of existing function off-platform in the distributed world as well, and there's no reason at all why this Netflix stack running on ZOS, which is how we ship it with base Zowe, can't be connected to a distributed server to be southbound of it, or vice versa. Actually, the API gateway can actually be installed. It's just a Java stack. It can be installed off-platform. It doesn't actually have to run on ZOS, which is how quite a lot of the development team developed that as well. So it can actually be used within an enterprise outside of ZOS. We deliver an installer that installs it on ZOS. And the two patterns that are the most common for extending the API gateway is people either have the white box on the bottom left called static registration. There's a lot of existing ZOS address spaces that already have REST APIs for either subsystems, existing subsystems like I know KICS or MQ or things like that. There are existing subsystems that already have REST APIs. So what we're trying to do is we're trying to introduce as many of those services as possible into the gateway. And you can do that to a pattern called static definition, which is where you teach the gateway about the presence of those services. There's another one, which is where somebody might have a ZOS address space that doesn't have a REST API, And there's a nice pattern there, which is you introduce a new REST API, and there's an extension pattern using Spring Boot and Eureka clients, which is basically where you can dynamically start up a Spring Boot server that's able to register itself with the API gateway. And how to extend, there's a link right at the bottom, which was a link I showed you on the previous one, if anybody has these slides. And if you follow that link, you'll go right into all the documentation about how to extend the gateway. And the next slide, please, Mike. And just to wrap up, the API Mediation Layer summary, I won't repeat everything written here particularly, but it's extensible, it's a single endpoint, it's an edge server, clients look at it, and it's a facade pattern. It hides the complexity of the services at the back end, and that's pretty much it, Mike.
All right, thanks, Joe. So I will move on and talk about the Zowe CLI. So the Zowe CLI is your client interface to ZOS, to the mainframe platform. Our goal with the Zowe CLI is to enable developers and DevOps engineers to work on the mainframe just like they would work on any other cloud platform, and allow them to make use of familiar industry standard open source tooling. If we are able to achieve this goal, we will address the skills gap by making mainframe development more attractive to next-gen developers, and we'll also improve the application delivery lifecycle by allowing mainframe applications to be integrated into existing enterprise DevOps pipelines. So the challenge that exists today is we need a good interface into ZOS. That is what we are offering as a solution in the Zowe CLI. We have all these tools that folks are familiar with, and scripting languages folks are familiar with, like Python and Ruby. CI/CD orchestrators, pick your flavor. In today's demonstration, we'll be using Jenkins. We'll be using a couple other common tools such as Gulp and Mocha.js in today's demonstration. But again, we are non-prescriptive. We are just the interface into ZOS, and you can make use of the tools that you want to make use of. So our interface into ZOS, the functionality that's provided in there is you can interact with data sets and USS files. For jobs, you can submit jobs, retrieve results, and more. We'll show a lot of jobs and files interactions in today's demonstration. You can also issue console and TSO commands. You can provision on-demand environments, create and manage ZOS MF workflows, and we also have additional plugins offered through Zowe, such as DB2, CICS, and IMS. So DB2, it allows you to run stored procedures and extract tables. KICS and IMS, our goal was to be able to deploy and activate these programs and transactions. And I'll move quickly into the demonstration. Just an overview of what you'll see in the demonstration is, first I'll tell you where to get the Zowe CLI, because that's one important takeaway. I'm going to show you what's possible today with it, but you can go to zowe.org and you can get the interface installed on your machine today. Then after I show a brief intro of a couple high-level commands, I'll abstract those commands into scripts and show how we can build complex automation for ZOS, demonstrate how the CLI can be used with other modern frameworks, and ultimately show how the CLI will enable the use of popular CI/CD orchestration tools for mainframe application. In today's demonstration, we'll be using Jenkins. So with that, let me transition into the demo. And really, before I start, one key point I want to touch on is the ability to use the tools that you want to use. So if let me pull up this developer survey. So this is a Stack Overflow survey of the most popular development environments. Folks today, we can see, want to be using Visual Studio Code, but again, we're non-prescriptive. So I'll show in today's demo, no matter what IDE you want to use, you'll be able to do that with the CLI. Just for awareness and how things have changed over the last year, here are the results from 2018. We can see that Visual Studio Code went from 34.9% up to 50.7%, which is one of the reasons we decided to build a VS Code extension on top of the Zowe CLI. So again, to get started with the Zowe CLI, you can go to zowe.org. You can learn about contributing, and there's lots of good information on this site. But if you just want to download and get started, you can click download. The command line interface has a separate install. If you click this, it'll ask you to agree to this end user license agreement. Accept that, and then it'll begin downloading the package locally. You can also download Zowe CLI from an online registry as well, and it takes you right to the documentation to get started. Now for today's demonstration, let me pull up. I already have the Zowe CLI installed. And today, for this demo, we will be examining source and automation that was built that's relevant to a sample CICS application called Marbles that manages an inventory of different colored marbles in a DB2 table. So just high-level interaction, you can start by typing the Zowe command. And it's built, help is built into the product, so you can sort of drill down and learn more as you go. So let's say, for example, I'm interested in the files command group. I can do Zowe files to see what actions are available under this group. For example, let's try to list available data sets. I can do Zowe files list. And here I see various commands. I can list all members of a PDF, I can list data sets, and I can list USS files. So let's do just list data sets, and let's look in bright top marbles asterisks. And again, I'm just in a terminal issuing commands. Now here, I am actually going directly to the ZOSMF service. But as Joe mentioned, I can go through the API mediation layer. So how that experience would look like is I'm looking at the API catalog that Joe had shown. I can go into the tab with the IBM ZOSMF API services, and I can find the host, port, and base path to configure the client to go to this this set of APIs. So let me copy off the host. Again, I can specify the host I want to go to, the port, and the base path. And again, this would all be available in the help, this information. So I'll show that as well. ZOSMF, I think that's correct. And he's now achieving the same thing, but going through the API mediation layer instead of directly to the API. And how he was working before was we have this concept of profiles in the CLI, which allows you to store your connection details for particular services for further use. But on each command, they're also exposed as options on the command line, so you can overwrite them. So here we see ZOSMF connection options. I overwrote the host, port, and base path, but by default it's using my ZOSMF profile, which is where the connection information was stored previously. Now, I can also run commands from any IDE with an integrated terminal. So here I'm in Visual Studio Code, and if I want to access those data sets, I have the Zowe VS Code extension installed, and I can access these data sets by typing in bright.marbles.asterisks. And my data sets will appear here, and if I wanted to edit a particular source file, I could click it. Again, you can get syntax highlighting in VS Code. type in COBOL, and I could make an update. So I could change user to users, and I could save this guy off. And this is a great solution for VS Code users. But again, I mentioned we were non-prescriptive. Let me just change this guy back. So you can use the CLI to download the data sets as well. So you can do Zowe, files, download, all members, write marbles.cobol. And I can specify an extension to save them as. So I'm going to do .cobol, and I will run this command. And he should download all these members into my working directory. So here I'm underneath Zowe CLI Workshop, Bright, Marbles, COBOL, and I see I've pulled all my source. So I can click in here and I can update these as well. So what I've shown here is I'm just in my working directory. So if you had a integrated terminal in whatever IDE you choose to use, you could use the CLI to make use of that IDE while working on mainframe applications. Let me delete him. Okay, so next I want to transition into writing some automation to abstract these scripts. So I'm going to pull up my gulp file. So I have this task that I wanted to automate. I wanted to automate the build of this COBOL program. So I want to show how we combined multiple Zowe CLI commands to achieve this function. So here we can see we have this var command equals Zowe job submit dataset, and in the CLI we have additional filters to help you parse the output. So here specifically, I just want to get the job ID from this command. So I'm looking for a response format field job ID, and the type of that is string. So if I paste this guy in and run him, he will come back with the job ID that was submitted. So it makes it easy to write scripts very quickly. If I copy that guy off, if we go down, that's what this command did. It submitted this command I just issued, and then it completed successfully. There was no error here. So then it goes to this function that's await job completion. Again, another thing that's nice in these modern IDEs, I can do things like peak definition and not lose the context where I'm working. So I passed the job ID that I had saved off in here, and I passed in a max return code, which was a 4. So if my job comes back and the condition code's greater than 4, I would fail my gulp task. In here, I'm just running another Zowe jobs command to check the status of that job. So I do Zowe jobs view job status by job ID. Provide my job ID, and again I can use these filters to just get the return code. So that's all I'm interested in, and he'll come back with he finished with condition code 4. So it met my maximum allowable return code, so the gulp task would complete successfully. If I come down here, we can see that I'm checking against max RC, make sure the one that was returned, the return code was less than that. So I would call back without an error. This is just a recursive function, so it would keep checking the status 30 times, waiting 1 second between each try, and that's what this does. If it's still in null status, meaning it hasn't completed, it just recursively calls itself. Okay, so I wrote that automation 1 time, right? There's some effort involved there, but now instead of having to go onto, typical mainframe interfaces and build this code every day, I can just run gulp build from my command line, and he will perform that task for me. So I'm starting build, and then he'll come back with finished build, and he's completed. Now, just like we built a VS Code extension for Zowe, we also note here that gulp, that's the framework I'm working in here, it has a extension into VS Code as well. So I could just double click this, and it would perform the build. Now also, we wrote automation to perform the deploy, which copies the program to the test environment, performs a bind and grant for DB2, and does a Kix refresh, which basically executes a Kix new copy command. So if I do if I double click on deploy, it'll fulfill this automation. And again, I want to highlight that you can be in any terminal. You don't have to be in VS Code. You could just be in a terminal of choice. So one example here is if I wanted to show the Kix command, I could do that. And again, I can make use of these formats. So if I want the format to come back as a table, I can. So here specifically, I'm looking at resources where the program starts with marb, and I'm looking for the program status and links. Can run this command. And we can see that the length of the guy I was working with, which was Marble 15, was updated from 0 to 11.536, which means that the program was enabled in CICS. Okay, so now if I go back to VS Code, I just want to recap quickly that our build and deployment automation consists of Zowe CLI commands that were abstracted into gulp tasks. Similarly, our test automation, it's in this test.js, but he's running in the Mocha framework, and he consists of Zowe CLI commands abstracted into Mocha tests. So again, very similar. Here's a test suite inventory manipulation. It should create a marble with cost 1. We can see in the create marble function that he issues a Kix transaction to update this to create the marble. And then he gets the marble quantity here, and I can peek that definition as well. And he does that by submitting a job and actually parsing the output of that job and verifying it's as expected. Okay, so now I got all this automation I can run locally, and I could trigger these tests with just npm test or Mocha test, and that would work fine for my local development. But now I want to show that being run in a CI/CD orchestration tool like Jenkins. So I want to examine this Jenkins file. And what a Jenkins file is it's a text file that contains the definition of a Jenkins pipeline. And this Jenkins file is checked into your source control. So anyone can go in and make updates and improve the pipeline. You'll notice that it has agent, label, Zowe CLI agent. This is actually, this pipeline runs in a Docker container that has the Zowe CLI installed in it. And then we are setting some environment variables here. And the CLI has this concept of command line precedence. So I mentioned before that I could specify the host and port to go through like the API mediation layer directly on the command line. I can also overwrite things with environment variables. So as an example, let's just pick a simple command, Zowe COSMF check status. He'll come back and he will tell me that I've successfully connected and I'm on this port. So I want to show that it was port 443. I want to export an environment variable called Zowe opt port equals just something else, 444. So, and then I will rerun the command. And he will fail. You notice he's going to port 444. And so what has happened is the environment variable overwrote my setting I had in my profile. Now I can overwrite the environment variable with direct input on the command line. So here I could change it back to 443 and I would be successful. Just let me unset that guy. So I'll port. Okay, so that's command line precedence, and I'll pull up the Jenkins UI in a moment, but we're making use of Jenkins Secrets. So here we have a credential stored in Jenkins, and its key is EOS host. And similarly, we have our credentials to interact with these systems stored in Jenkins as EOS creds. And the reason you do that is you don't want to source your creds or have them viewable. You want them to be secure, and these are secure in Jenkins Secrets. So if we transition from the environment directive into the stages directive, we can see we have a variety of stages. So we have local setup for our project, then we perform the build, which is the same task I had run earlier, the deploy, again, the same task, and finally we will see our test run. And then I have a post step that will publish the results of my test runs so that they will be, available for, let's say, audit purposes, right? Let me now transition into the Jenkins UI. Here I'm in the Zowe CLI workshop. I'm going to the master branch, and I will select build now. And while he's running, I want to talk about the secure credential store. So again, if we go to this space and I go to the credentials, I can see here that, and we can just look under Zowe CLI workshop. Here I have a credential for the EOS system. And if I click on him to, let's say, update, we will see that his ID is EOS creds, which is exactly what the Jenkins file was keying off of. Similarly, for credentials, we're looking for EOS. So EOS creds, and now I'll show the EOS host piece. So I go back, and I go into EOS host. So let me see. Host name for EOS system. Let me go back real quick, update. We'll see he's EOS host, and that's the key he's going off of. One really interesting feature for maybe audit purposes, or if you're interested in where these credentials are being used, you can just click on them here and it'll tell you they're running in certain pipelines. So 14 is the pipeline I just kicked off, so we can easily return to our pipeline here. We can view this in Blue Ocean, which is just a more modern view of the Jenkins UI, and we can see he's into the test stage. So I just want to show some of these steps while the test is running. Here I do just a local setup. So I do these -s versions just to share with you what's in the Docker container I'm using in the pipeline. So I'm on node 8, for example, Zowe version 2.15. I can list the plugins that I have installed in this image. And then finally do the npm install, which installs my dev dependencies for this pipeline, like the Mocha tooling that I'm using or the Gulp tooling that I'm using. Then I perform the build, which is similar to what I showcased in Visual Studio Code earlier. I do the deploy, which is similar. Again, all this interaction, it's abstracted on top of the Zowe CLI. So Zowe CLI is the driver of this EOS interaction. And then we can see the test suite runs. See the inventory manipulation. It's just checking, going through the test. So it should create a marble with cost 1, etc. And it creates this report, and then my post step archives it. So if I go into artifacts, test results, here I can see the test results from this run. I can look into details of what each test consisted of. So again, I spent some time to build out the automation, but once the automation is created, I get those benefits, basically forever now, and we can continue contributing together into the pipeline to make it more robust, and everybody can benefit from it, and our quality and speed of delivery should improve. So with that, I will go back to the slide deck. And just maybe we can wrap up by taking some questions. And to learn more, again, just visit zowe.org. And as I mentioned earlier, for the CLI, it only takes a couple of minutes to download, as I showed. You can get started today. And if you have any questions, you can feel free to reach out through any of the channels listed on zowe.org, such as Slack.
All right, great. So we have about 10 minutes to the top of the hour. And so with that, we have a few minutes for questions. We've gotten some great ones in, but there's time. If you have a question for either of our panelists, please just use your GoToWebinar control panel and get to and submit your questions. We'll get to as many as we can. Okay, here's the first one. What does Zowe base its workload balancing on?
Yeah, sure, I can try and do that. So the basic workload balancing algorithm is quite a primitive one. It's quite a basic one, and I think it's based upon response time. So if there's a number of servers available that are all registered for the same service, then the gateway will check the response time and use that as a gauge of health of the servers. There are some more sophisticated ones available, and the API Mediation Layer squad is definitely looking to enhance that, so that things like whether a particular server is sick or the health of a server is something that the gateway can query from the server. That obviously requires the server being able to answer that, whereas response time is quite a primitive one, because that needs to be monitored by the server rather than the server having to have those additional health APIs available. And I also believe on the base as well as response time that it can just do round robin. So it just rattles through the number that are there and just hits them all in turn.
Okay.
But if anybody's interested in more sophisticated ones, please get involved with the API Mediation Layer squad, because I know they're looking to expand out the capabilities of it.
Okay, great. Next question. For developers who already have a full install of Visual Studio, can the Zowe plugin be used in Visual Studio?
So the Zowe plugin is specifically used for Zowe or for Visual Studio Code. But if you're using the Visual Studio IDE, you could easily pull and interact with data sets by using the CLI, as I had showed, the Zowe files download all members command. So you could pull them really easily locally, and then you could just upload them back. I also did a presentation recently on where you can also use a Git client to manage those data sets locally. So you would basically initialize a Git project, and then you can take advantage of all the Git merging capabilities. So you could have a counterpart working directly on the mainframe, for example. You could branch to do your new feature, switch back to your master branch to pull your mainframe counterpart's changes, and then you could merge in and you could make use of Git today in that environment, local Git, to handle your merges.
All right, excellent. Next question. While Zowe framework includes extensible capabilities using CLI or Web UI, is the fundamental decision of building extensible capabilities using CLI or Web UI related to cycle offload? If not, what is involved in that decision?
So I don't think Zowe prescribes anything about whether CLI or Web UI should be used. I think Mike's demo was really good, because what Mike did was he was able to bring existing tools like Jenkins and Visual Studio Code to Zowe, and the sort of touch point for that is really a command line interface. And there are other DevOps tools out there that's the sort of intersection point that they want to intersect. And Zowe, we want to make it a very non-prescriptive experience. So if somebody has an existing tool and they have a problem with making that existing tool work with the mainframe, CLI is a very good way, because that existing tool can probably talk CLI and it's scriptable. Web UI is a very different. Web UI is really designed where you're being operated by a user with a set of eyes and fingers on the keyboard, and it's just a choice, and we don't prescribe any one. That's really for a usability team to do.
Okay, all right. I think we have time for one more question, and let's see. So if we use the Zowe CLI to build CI/CD pipelines, what does the IBM DBB product provide that CLI does not, since we can run capital J, capital O, capital B, capital S's to run compile programs, or to compile programs, run jobs to pre-built unit tests? Hopefully that makes sense.
It does. Mike, do you want me to have a stab at answering that, or?
Sure, you can take first crack and then I can follow up.
Okay, so DBB is dependency-based build, which is an IBM commercial product. It's a very good product. I'm not the product manager for that product. So if anybody wanted more detail about that product, I would suggest that they work directly with that team. DBB is really about trying to advance DevOps on platform, I would say. So a lot of the infrastructure behind DBB involves having GitHub on host and involve advancing the file system towards the Unix file system, which basically means that more on the mainframe tools can be used for the DevOps pipeline. Whereas I think what Mike showed for the CLI, everything that Mike showed is free, is freely available. It's not a commercial offering offered by IBM or any other vendor in that space. Mike was coming at it from a slightly different angle, which is about adapting existing tools where there was no, for example, there was no Jenkins client installed on the mainframe when he did his Jenkins. Jenkins was just talking through the CLI to the mainframe. So the mainframe had was able to work with just ZOSMF as being the only prerequisite. Whereas DBB has more software installed. It's a more mainframe-centric DevOps world.
Yeah, I'll just add a little bit. I'll add a little bit to that. So also, a key point we like to highlight is we're non-prescriptive, and we also don't require folks who have been working on the mainframe for a significant amount of time to necessarily adopt this new technology. So if you have existing build logic on the mainframe, you can orchestrate that with the CLI from your Jenkins environment. So I think that's another key piece, is that you don't have to move your build logic into another tool. You can simply orchestrate and make use of that existing build logic that exists today on the mainframe. So as an example, to perform my build, I was orchestrating that through a CLI command, but behind the covers, I could be making use of an existing piece of JCL that has done that for me for years. I'm just now automating that.
Yeah, and DBB as well does provide DBB dependency-based builds. So to set a build up, DBB provides a lot of value in actually analyzing the dependent artifacts that need to be built. So for example, if you change a copybook, that will have an impact downstream on the COBOL or the PL1 programs that use that copybook, and then it gives you that high-level view of the map of everything that needs changing in a pipeline. Very much, that's what the dependency-based means. The two are complementary as well.
Okay. All right, great. We are about 2 minutes to the top of the hour, so unfortunately we do have to close out the Q&A session. I do want to thank everybody who did submit questions. If we didn't get to your question, I am very sorry, but please know that the folks at IBM and Broadcom will be getting a copy of the questions, and hopefully there'll be somebody from the organization following up with you offline to get your question answered. Before we close things out, I do want to do our quick drawing for the 3 $50 Amazon gift card winners. So without further ado, our first winner is Rob Strebel. I think it is. The second one, congratulations, Rob. Our second winner is Mauro Piccinini or Piccinini. I'm not quite sure how to pronounce that, but I apologize because I know I got it wrong. But congratulations, Mauro. And our third winner is Vikas Pujar. Vikas, congratulations to you. Congratulations to all three of our winners today. And Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to listen to it again, you will have the opportunity to do so. We are sending out an email post-event that will contain a link to take you to the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always find it there. Just go to the webinar section on the site, click on demand, and it should be right there waiting for you. And while you're there, please check out the other webinars that we have, both upcoming and on demand. Hopefully there'll be 1 or 2 or 3 or 4 that pique your interest. Gentlemen, thank you. Michael and Joe, thank you so much for such a great presentation, lots of great demo stuff. I always love to see that. So thanks so much. Appreciate it.
All right, thank you. Thanks, everyone.
Great, thank you.
Thanks, Charlie.
Thank you, and thank you also for joining, to the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.